say that the furnace must be specifically configured when using 90% iron material. It doesn't really matter at this point. The furnace must always be configured considering the refractory kind of material, which is why all the necessary changes must be made in electrical and slag melting regimes. What were the main negatives that couldn't be neutralized? I would say that the main negatives are the overall melting cycle time, the total amount of time. The increased energy consumption is, of course, a big deal, and the specific electrode consumption. But comparing the price of high-quality slag and scrap, I would say that results are pretty good. Factories often refuse buying slag due to its inhomogeneous mixture. How do you deal with this problem and how often it happens? Every now and then it happens, yes. To avoid trouble using slag that contains admixtures, I would definitely recommend decreasing the overall load. If it happens so that the chemical analysis is negative, then there's a dividing method. You can apply it at the furnace ladle area. Some factories use hot iron briquettes or the same kind of metallized pellets. So at that stage, those can significantly neutralize the admixtures throughout the melting process. We produce slag that contains up to 2% of phosphorus and sulfur. How do you think we should deal with those harmful impurities? Okay, so first thing we need is to figure out the optimal quantities through balance melting. Obviously, the steelmaker is capable of reducing the amount of phosphorus on the early stages while working on the cool slag. And a certain amount of sulfur can be reduced at the ladle furnace. So I don't really see much trouble processing that kind of slag. We certainly can't use all of it, but by applying balance melting, we can easily use some of this slag. Would you say that most factories are ready to face these changes? Time will tell. We monitor and follow the scrap situation, and the fact is that with each year there's less quality scrap, and that factories tend to switch from open heat to electric arc furnaces. That's why I think that slag remelting technique is here to stay. And the key thing here is the clever and smooth transition from the existing power management. Energy and technological regimes must be configured.